Okay, let's continue on. So we're here. We have CA or ACR. So that's going to be just the part here. ACR. So it's going to be 54. So you're going to put that in. 54. Our last one up is ACT. You said? 116. And then the last part is just side lengths. So CT is across from AR, so that means it has to be 12. And then RT is across from AC, which is 10.
Is that a phone right there?
Our first one up, how many sides does this have?
6, 8.
8. What do we call an 8-sided object?
A hexagon.
Octagon. Woo! Over 2. It's okay, we have time. Is this one going to be a polygon?
No.
No, why not?
Because the sides ain't closed.
Yep, not closed. Okay, number 3, is this going to be a polygon?
No.
Why?
Because no straight angle.
Yep, it's not segments, it's curved. Okay, our next one up, is this going to be a polygon?
Yes.
Yes, what is it? Heptagon. There's 7 sides, so it's heptagon. Okay, after this one, you guys have to have some information that is not given on the page. So here, there should be a 72.
What's that word, served?
Curved, it's curved. And then here, I can see what you're seeing. It's the word supposed to say, it's curved. And then this one's supposed to have a 37. And then now we should have enough information to solve this group. So let's get going on that. So same as the last one. We have 360 minus 110 minus 72 minus 65, which is? You got 113, you said? 113. Okay, over here, we have to find this missing angle. So that's going to be 360 minus 90 minus 90 minus 37, which is? 143. Okay, the next one tells you it's a parallelogram. Remember, in parallelograms, opposite angles are congruent. So that means 116 for angle C, or 122. Ooh, let's try that again, Jenkins. 122 for angle C. And then you know consecutive angles are supplementary, so 180 minus 122. What's 180 minus 122?
68.
A little less than that, but you're close. 58. So 58, and you know opposite angles here, again, congruent. So 58. Up here, I think you have to be given another piece of information. You do. Yeah, you have to be given 5 and 8. So this is supposed to have an 8, and this is supposed to have a 5. Add that in, and then we'll solve it from here. So if PS is directly across from QR, so PS also has to be 5. SR is directly across from PQ, so it also has to be 8. QS is the whole length. How long does that have to be? It has to be 6, yep, because you know this part is 3 because it's been bisected. How long does TR have to be?
4.
So be careful, it's just the lower part, so it's just the 4. Okay, and then the last one on this page is about finding the mid-segment. You guys remember the formula for mid-segment?
Nope.
So that is MN, so mid-segment equals 1/2 B1 plus B2. So it's going to be 1/2 14 plus 22, which is going to be 1/2 times 38, which is? Ooh, nope, 36. Which is? 18. So your distance here is 18.
I can't fix the bottom.
Oh, I'll bring it up. It just says 1/2. 1/2 equals 36. So up here for the first one, we want to find the value of AC. If then the rhombus, what do you know about all the sides?
It's a bug there.
Yeah, it's a ladybug. So what do you know about the sides in a rhombus? They're all congruent, so AC also has to be 5. Okay, we know ARC is what I'm looking for next. ARC. So that's this angle down here. You can hardly see it. What's this one? What's this one have to be? 40 because alternate interior angles.
Is that a 50 on the bottom?
Yep, it's a 50. And then we want to find RAC. RAC is this whole length up here. If this one's 50, what's this one have to be? It also has to be 50. So we know ARC has to be RAC. Has to be 100. 50 plus 50. And then our last one is ASR. ASR. So we're looking for this angle right here. We don't have that yet. But what do you know about, in a rhombus, what do you know about the diagonals? They do what? They're perpendicular, so it has to be 90. Okay, the next one up is that weird rectangle. We can do AC first. What's the distance of AC have to be if you know BD? It has to be the same. So we know that that also has to be 10 because in a rectangle, diagonals are congruent.
We didn't get that.
Yep, you guys had to add it in.
It's not up there.
No, it is. It's right here. It's in the problem, yeah. And then we have BE, which is part or half of BD. So what is half of BD? 5, yep, because it's been bisected. And then we have a whole group of angles we're going to have to solve. So we know that the total here is going to be 90 because they have right angles in a rectangle. So this is going to be 90 minus 60. So this angle has to be 30. Over here, you know that this angle has to be 60 for the same reason. 90 minus 30. This one is going to be 30 alternate interior. This one's going to be 60. And then this one here has to be 60 as well because alternate interior. So let's go on to BCE. So BCE is this angle down here. So that's going to be 60. Our next one is BEC. BEC. That's this angle right here. What's that one have to be? It has to be 60 because it's 180 minus 120. So here we also see it's an equal angular triangle. 180 minus 60 gave us that 60. We have CBE. CBE. That's 60 again. EBA. EBA. That's 30. We have CAB. CAB. That's going to be 30. Make sure I'm not confusing any of these. And then we have BEA. BEA is this one right here. We have to do some math. 180 minus 30 minus 30, which is going to give me 120. Okay. The next one up, we have to find the value of x. So we know this is a parallelogram. What do you know about consecutive angles in a parallelogram? They add up, yep, supplementary, add up to 180. Is that what you got for your full answer? Okay, so we get 6x plus 56 equals 180. Subtract over 56. We get 6x equals 4 to 124. Double check my math. Divided by 6. X equals, I have a decimal.
I did something. That was wrong.
20.7. Okay, so we're going to put 20.7 in here. And then to find UDT. UDT. That's this angle here. You know opposite angles are congruent, so we're going to substitute in here. 4 times 20.7 plus 4. 86.7. Okay, and then here we're going to substitute in to find SUD. That's this angle right here. So it's going to be congruent to the angle opposite of it. So we're going to do 2 times 20.7 plus 52. So 41.4. Is that right? Plus 90, so 51.4. No. I'm going to trust you. You have a calculator. 93 point what? 3. Okay. Okay, and then our last one up on this page, we're getting close, is this is a square. So we want to find the measure of angle ONL. ONL is this angle right here. Well, you have to know stuff about squares. In squares, we know that all the angles are right angles. We also know that it's a rhombus. So we know that all of the angles at the center are also right angles. So what do we know about this angle? What does it have to be? It has to be 45, yep. Because this has congruent sides. We know this is a right angle. It means our angles have to be congruent. So it's going to have to be 45 degrees. Our next one is MNL. MNL, that's this one right here. What's that one going to have to be? 45 degrees. Yep, same reasoning. And then we have NQM. NQ. So this one, be careful. NQM is, which one? 90. And then we have NL, or NML. NML. What does that have to be? 90. And then it wants us to find the perimeter. What do we know about the sides inside a square? All the sides are congruent. So it's going to be 6 plus 6 plus 6 plus 6, which is 24. So in a trapezoid, we know that these two angles are going to be what? Supplementary. Yep. So to find this one, it's 180 minus 63. To find this one, it's 180 minus 104. 180 minus 63 is going to be 117. 180 minus 104 is 76. Over here, this one tells you it's an isosceles trapezoid. That means that these two are going to be congruent sides. Base angles of an isosceles trapezoid are congruent. So that means angle L also has to be 72. So then to find angle K, we do 180 minus 72, which is 108. So 108 for angle K. And then for angle J, they're going to be congruent because it's an isosceles, so it's also 108.